Everyone, in the last IXL video, I'll show you how to decide what numbers and units will be more precise, and then you're going to talk about greatest possible error. I think that was what it was called. Okay, we will see that after this lesson. Okay, so the first question is, I think all of the questions are going to be the same. Which measurement is more precise? When we have those sort of questions, the first thing that we look at is the numbers given. We ignore the units first. Actually, let's just look at the units as well. So the units are the same, right? You see that millimeters and millimeters. So the units are the same. So the numbers are going to tell me the difference. So the more precise your number, the more precise your measurement, if the units are the same. Looking at these numbers, which one looks more precise? This one gives you like 0.9. It's not just 33 millimeters, or 32. It just says 32.9. It's just more focused. It gives you more detail. So this is called significance of the number. So in here, 3, I'm looking at 32.9. 3 is a significant digit. It's in the hundreds place. 2, my bad, 3 is in the tens place. 2 is in ones place, and then it is a significant number. 9 is also a significant number in there, and then its place value is, let's see, it's in the tenths place. In here, we have tens and ones. We don't have the tenths in 94, so this is more precise. That would be my answer. Okay, if the units are the same, the more digits you have after the decimal points, I'm just simplifying it now. I made my explanation and I explained the reasoning. Now I can give you the shortcut. The more numbers you have after the decimal point, the more precise your answer is. Okay, now let's move on to the next level. I'll pause the video. Okay, in this question, by the way, I'm re-recording this because obviously I didn't hit play, and then I kept solving the question, and then in the end I realized I didn't even play it, so I couldn't pause it. Now I'm resolving this question. Okay, which measurement is more precise? So I'm looking at the numbers. 84, it has tens and ones in there. 8 is in the tens place. 4 is in the ones place. Same thing for 21, tens and ones. So there's no difference between the numbers' place value. So what I do is I look at the units, gram and kilograms. So gram is always more precise than kilograms. That would be my answer. And here is kind of a visual for you that tells you how you can decide whether your unit is more precise or not. Oh, not centimeters, centigram and milligram. Okay, as you go down, it gets more precise. That's not how you spell precise. What am I doing? Okay, let's just, if I didn't say anything, probably you wouldn't even realize that, guys. Okay, so it gets more precise, right? So that's why 84 grams would be my answer. Let's see the next level. Okay, here we have 21.8 days and 8 years. So because of two reasons, this is going to be more precise. First, days is a smaller unit than years. That's one reason. And then second, the unit has more significant digits than 8. So the last significant digit is in the tenths place. It's more precise than just saying 21 or 22. It gives me more information. So we have one more question after this. Okay, same reasoning. The number of the last significant digit is in the tenths place, 0.8 and 0.9. So the units are going to tell me what my answer is. This is more precise. Ours is a smaller unit than days, so that would be my answer. So let's see the next IXL assignment. Okay, here's the last assignment of the week on IXL. It is TZC greatest possible error. On IXL, this lesson is pretty simple because all we are going to do is find one number and divide it by 2. That's all what the assignment is about on IXL. It'll get deeper when we get on study island and confusing probably. You may need some help with tutoring for this part of the lesson and for E5. Okay, so the question is, what is the greatest possible error for a measurement of 5 feet? First, find the place value of this number. 5 is in 1's place. So you take that place value, which is 1, and divide it by 2. It's 0.5. So that's the greatest possible error, or in another term, it is also called margin of error. This is the phrase that Study Island uses. So the answer would be 0.5 feet, the margin of error, or the greatest possible error for this 5 feet value. Let's see the next level. Okay, as you see, this is the next level, and there's no other level because it's kind of frozen. I cannot click on it. That means all of the questions from this point on is going to be the same. So this is going to be the last example on IXL that I'm going to do in this video. What's the greatest possible error for a measurement of 2 miles? Same thing. Find the place value of 2. It's in the 1's place, and divide it by 2, which is 0.5. So I don't want you to end up with like 32 miles in a question and then be like, Mr. Abdullah didn't show me this. So hear me showing you how to do that 32 miles. So 3 is in the 10's place, right? And then 2 is in the 1's place. The last number is what we care. So since the 2 is in the 1's place, I still take that 1 and divide it by 2. 0.5 would be my answer. So I also don't want you to be like, Mr. Abdullah didn't teach me how to find this 45.7. So here we go. Let's do this one. Let's say our number is 45.7. Find the last number in your number. Find the last digit in your number. That would be a better expression. So this is the last digit, and its place value is the tenths. A tenth is 0.1 or 0.10. There's no difference between them. And then once you have this number, you divide that number by 2. This time you will end up with 0.05, which would be your greatest possible error or margin of error for this number. Thanks for watching, guys. Let me know if you have any questions or issues. I'll try to help you as much as I can, and I will see you in another video.